Good morning, sir. My name is Tejas Jagtap. I am from TYB Tech. We have done ISE of digital signal processing, in which we have written two programs on Matlab. First is Matlab program to demonstrate adaptive filtering using RLS algorithm, and second is Matlab program to generate ringing sound of telephone. So my group members are Prathamesh Mane, Adhiraj Mali, and Indrayani Patil. I am going to explain the program for RLS algorithm. So this is the program. We have written CLC for clearing all the command window and clear all to clear all the variables created in the workspace and close all to close all the figure windows earlier opened. So here we are going to generate four signals. First is the desired signal. Second is signal corrupted with noise. Then we are going to obtain adaptive desired output using filtering. And fourth is error signal. So we have written here program for desired signal, which in which t equal to 0.001, which means start the signal will start at value 0.001, and it will take a step size of 0.001 up to signal will be up to 1, which means the total number of samples will be 1000. And this part is the trigonometric function of the desired signal. So further we are going to generate a noisy corrupted signal. So n equal to numeral of d, where n is a variable which will store the value of the number of elements in the desired signal. This DISP of n means uh, which will display the signal. And here this part is the actual signal equation, which will be containing the desired signal as well as the noisy signal. And eta is a variable which is used to store the value 10 raised to 4, and I equal to ones of 1 comma n, which means it will hold the all the values equal to 1 up to n. And r is a variable used to store the result of multiplication of eta into I. And w is the weight factor which will hold all the values uh, to 0, starting index 1 up to n. So that much part is to generate the signal. uh, Further we have written the program for filtering. So for that we have written using for loop. So for I equal to 1 colon n, which means it will start iteration at 1 and it will continue up to n. So y of I equal to w of I into complex conjugate into convolution of a of I, which means which it is a output signal for which we have written the equation. And ERR of I equal to d of I minus y of I, which means uh, we are going to generate error signal using the subtraction of the desired signal from the signal corrupted with noise. And the further part is written using the derived equation of the adaptive filtering using RLS algorithm. Remaining part is that to in order to obtain the desired signal from the using after we have written the filtering. So for that we have also written for loop. For that we have written for I equal to 1 colon n, which means the iteration will start at 1 and end at n. And b of I equal to sum of w of I into complex conjugate into convolution of a of I. For that we have written the code. So this much part I am going to explain. Further part will be explained by Prathamesh Mane. Thank you, sir.
Thank you, Tejas. First of all, let me introduce myself. I am Prathamesh Mane, ARN number 2005001. I am going to explain display of signals. For display purpose, we use subplot command in which 4 rows, 1 column and 4 cells are assigned to first cell of first plot, and we give input argument D. Then we give title as design signal. Then we go for second assignment. We we subplot 4 comma 1 comma 2, 4 rows, single column and second cell, where input command is capital A. Then we give title uh, signal corrupted with noise. Then we go for third assignment, which is subplot 4 comma 1 comma 3, and then we plot B, and we give it a title as adaptive design field output, and then only one subplot remains, which is subplot 4 comma 1 comma 4. Then we plot error, and we give title as error signal. For the further part, I would like to invite Indrayani on this platform. Thank you.
Thank you, Prathamesh. Now, first, let me introduce myself. My name is Indrayani Patil, and I'm from Electronics and Telecommunication Department. And my PRN number is 2005066. So, without any further delay, let's move towards our presentation. So, as we run this program, we see four signal output. In the first one is desired signal, as we have four rows and only one column in the first cell. In the second cell, this signal is corrupted with noise. So, in a third cell, according to use of recursive type of least square algorithm, which is RLS algorithm, we have the adaptive algorithm design output, in which in which is plotted into third cell, and the error signal is the different signal is plotted into the last cell. So this is all about. Thank you.
Hello everyone, my name is Adhiraj and today I'm going to show you a Matlab code which generates a tone, and we'll be utilizing a sine function right over here, and we'll also be utilizing sampling theorem. So see, I have here four variables: frequency, duration, sample rate and time, and another one which is tone. That's our actual function which are going to play. See, frequency I have given any random number. I chose 440 for that, and duration is 2 seconds, sample rate is 44100, and time, look at this carefully, my time will start at 0 seconds and it will be ending at duration, and in between I have written 1 upon sample rate, which becomes the sampling frequency. So 1 upon 44100 times my time will be recorded from 0 to 2 seconds. My time will be broken into that many pieces for recording and utilizing into the next function. So tone will be sine of 2.2 frequency into time. That's what. And this line is input. Press any key to play the sound. Input function basically waits for any string, and then what it will do is when you press the enter key, it will execute that next line of code which I have written. So the next line of code is sound. Let's run this code and see how this functions. Let me press any key. Wait for it. It should be working. There you go. And this was a simple code, but what I found out, if I insert a similar frequency, just a little bit more or less than 440, and another sine function in which the frequency value is the next frequency value, and then if I add both of these functions and produce another function which is the addition of both of the previous functions and try to play that function, it will sound like just how our phone rings. Okay, see, look, this is our code. So phone ring, I have named it as phone ring. See, I have two frequencies, 440, 480. The duration I've kept it as 5 seconds, and the sampling frequency, rather than giving the sampling time, I'm giving sampling frequency. So it is 64100, and y1 and y2 are both of the functions. And here in this line, I've added both of the functions, both of the sine functions, and sound y. This function is actual what playing our sound. Let us see how this works. That's what. It sounded just like my phone ringing. Thank you guys. This was it.